Sir, your mic's muted.
Okay, thank you so much. All right, okay. I was just waiting for a few guys to join in, but I'm surprised out of all the two classes, I've got only 12 people. It's I don't know what's happening. Are you, my goodness, what happened? I closed my Visual Studio. Oh my goodness. Oh my God. Oh my goodness. Oh yeah. Let me try to open this this other machine, because this laptop will take some time to load Visual Studio. Okay. All right. Oh, Bravish, Darin, Gabriel, my bestie, Sekufatso. All right. Bongani, Ibrahim, Mr. Melds, Marcelo, Shane, Yetin. What's up, guys? Lela is joining in as well. Okay, you are welcome. I'm trying to connect another. I'm on campus today. I'm trying to connect another school PC, because this laptop takes time to switch on Visual Studio. I closed it by mistake. But let's see. Okay. You can use another machine. Let me just see quickly. All right. Okay. There we go. So I think I've seen from the topic today, we are looking at what? Learning unit number 2. Learning unit number 2, pointer types, pointers and unsafe code. Pointers and unsafe code. That's learning unit number 2. We are going to use pointers to access code, to access data. We're going to use pointers to access data. We need to access some data using pointers. So now the question is why? Number 1. Number 2, then what are pointers? So we just need to look at those things. Then that's today's lecture. What are pointers? And why do we use pointers? Should we do our coding in what in using pointers or what? Okay, so we look at those things only today. Then I'll be out of your way. Then the rest of the time I'll give you a task which you're going to do. Okay, so the question is, what is a pointer? The question is, what is a pointer? What is a pointer? Any try? What is a pointer? What is a pointer? What is a pointer? Pointers, 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 pointers in programming. What is a pointer? Okay, let's see any tries. Pointers, 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 pointers. What are they? Any clue or wise guess? A location in memory. Okay. Oh, that's Google. Dr. Google. Okay. Oh, that's correct. That's correct. It's a location in memory. Pointers. It's a location in memory. Any other variation? Another variation? Any variation? Any variation in as far as pointers are concerned? It's a variable that stores the address of another variable. Okay. Or I think that's now um, more precise. Exactly. That's now more precise. Okay. So basically, we just want to look at that. We just want to look at that instead of referring to our variable, we refer to the location. Instead of referring to the variable which you're using, we refer to the location. We refer to the location. Then you can do your coding, your programming, using only references, using references, using reference. So it's a reference type. It's a reference type. It's a reference type whereby you are addressing some elements indirectly. Now the question is, why do we do that? Why? Why can't we go direct? Why? Why are we using pointers? Why are we using pointers? Why are we using pointers? Okay. Why are we using pointers? Why can't you just go direct? Why do you have to use a reference? Okay. Why? Why do you have to use a reference? Okay. Or in terms of security, that's good. In terms of security, it's good in terms of security. Um, it's good. Like those guys, if they want to inject, their, their what's this? I'm forgetting this topic now. It deals with computer security, whereby they inject their SQL, we call SQL injections, where they have their all those kind of cyber attacks. Yeah, that's where it's coming from. So if we're using references, so it's kind of a what? It's kind of a defense. It's kind of a defense. It's kind of a defense, although not 100%, but it's kind of a defense as well. Okay, there are so many reasons. Last time I checked, there were more than 10 reasons why should we use pointers. Any other reason? Any other reason why we should use pointers. Okay, I think the laptop is getting, I think the laptop is getting there. All right. Okay, create a new project. Then so let me try to open a project. Was creating a new one can take some time. On this, let me try to create a project. Okay, I'm almost getting there. I'm trying to log in using two machines. What do I need here? What do I need? What do I need? What do I need? Okay, just a simple console application. Just a simple console application. Do I have one? Console application. All right. This is pointers. Then what's happening here on this other machine? Nothing is happening. Right. Let's see. Wrong passwords. Okay. Right. Sign in. Update password. There we go. Courses. Prog 7312. Where are we? Prog 73. Now let me use group 2 to access. Because group 1 I'm logged in already. Use group 2 to access. Group 2, group 2, group 2, group 2 to access. How to access? Okay, via announcements. All right. Pointer types. Oh, I have to join in as a guest, or I won't be able to do anything if I join in as a guest. So let me go back to group 1. Blackboard collaborate. Blackboard collaborate. Okay, let me try to disconnect this laptop and use the school PC. This. Jesus Christ. What kind of foolishness is this? 1, 2, 1, 2, sound check. Oh my goodness. I was on mute all this time. Just imagine. Oh my goodness. Oh my goodness. Oh my goodness. Oh my goodness. Yeah, 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 yeah. I had to get some earphones, try to plug it in, try to do this. My goodness. I'm sorry, guys. Huh? I'm sorry, guys. All right. Without wasting time, without wasting time, without wasting time, without wasting time. Session is being recorded. Can I check? Yes, being recorded. Right. Okay, who is this Angela Bay? Darling. Hey, 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 hey. Who is this Angela Bay? Okay, so right, there we go. There we go. Right. We are doing what? Pointers and unsafe code. Pointers and unsafe code. Pointers and unsafe code. So we've defined pointers already, and we're working on the reasons of why pointers are relevant. So you mentioned some of the reasons. One of them is also that, pointers are much closer to the machine language, right? Pointers are much closer to the assembly language. Assemblies, I'm not sure, I think we'll do a topic on assemblies later on assemblies. So they are much closer to the assembly language. So it means, we issue less instructions, or the compiler interprets less instructions when working with pointers. So which means, since they are closer to the assembly language, so which means they result in what? They result in efficient programs. They result in efficient programs which are quick to execute. Unlike all those other programs which you do, we've got lots and lots of translations. We've got lots and lots of those, lexical analysis, syntactical analysis, changing from one form to high level to low level, blah blah blah. But pointers are much closer to the addresses, the memory addresses. Okay, so it's one of the reasons why we are teaching you these pointers. Okay, why we're teaching you these pointers. Of course, it's not encouraged to work in those areas. It's only sober people, and people who know whatever they are doing. The rest of the guys, you are not allowed to work with pointers. The rest of the guys, you are not allowed to work with pointers, especially if you drink too much. We don't allow you to work with pointers, right? The rest of the people, they're not allowed to work with pointers. It's only sober people. Why? Because it's regarded as an unsafe zone. It's an unsafe. So that's why the topic is pointers and unsafe code. Pointers and unsafe what? Pointers and unsafe code. Unsafe. It's not a safe zone. It's not a. It only requires sharks, that can swim those deep depths. The rest, you have to be like, those small fish. You must be on the shore, on the shoreline. Only sharks, they must go deep. So pointers, this is for deep. This is deep stuff. It's for guys who go for depth and who know what they are doing. Otherwise, you end up formatting the whole RAM. You end up formatting the whole RAM. You format the whole RAM, just formatting RAM, format. Why? Because memory addresses. Remember, you're working with memory addresses. You're working with memory addresses. So you're working with the heap, you're working with the stack. So you may end up messing up the whole thing. So you are not allowed to go there unless you are authorized, or unless you know what you are, unless you know what you're doing. Why? Because it's an unsafe zone. It's an unsafe zone. Okay. Right, demonstration of pointers. With pointers, right. let me have a formula to calculate the area of a square. Area to calculate the area of a square. Remember, our chapter is accessing data using pointers. How do you access data using pointers? How do you access data using pointers? So, all right, I want to have a formula for calculating the what? For calculating the area of a square. So, public int, or just the area of a shape. Public int square, public int square. All right, public int square. For the square, we need what? We need int. Let's need int I. Yeah, for the square, because the square has got the same side. So it's int I, not int one. It's int I. Okay, there we go. Right, there we go. Return I. Then I multiplied by what? Then I multiplied by I. Then I multiplied by I. Then this is using the normal way which you understand. Now let's use pointers again to achieve the same thing. Let's use a pointer. Let's use a pointer to access that data. Let's use a pointer to access that data. Public public void square. Public void square. Now, how do you declare a pointer? We use an asterisk. We use an asterisk to declare a pointer. So int, then you put asterisk. Let's just say our pointer is now pi. We use an asterisk int pi. Then the result, everything, we're working with pointers, the result of this is going to be stored in another pointer again. The result of this I multiplied by I, it will be going to be stored in another pointer. So pointer pi is equal to pointer pi multiplied by pointer pi. So pointer pi multiplied by pointer pi, the result is stored in pointer pi. These are memory addresses. Pointer pi multiplied by pointer, blah blah blah. There we go. Then there's a problem. There's a problem there. There is a problem. All right. Are you following, guys? Do I have my faithful students? Yes. Leila
Yes,
is
sir.
running away. You're following. Oh, that's good. As long as my bestie confirms, I'm sorted. So there we go. But there's a problem now. There's a problem. Check. You put your cursor there. What's the problem? Pointers and fixed size buffers may only be used in an unsafe context. It's not a safe zone. Hello? It's not a safe zone. There we go. Pointers and fixed size buffers may only be used in an unsafe context. It's not a safe zone at all. It only requires sharks, sharks who know how to go deep. So it's not a safe zone. So how do you deal with this problem? So you use this keyword unsafe. You use the keyword what? Unsafe, number one. Or you can declare the class as unsafe. The class is what? Unsafe. You see? Unsafe, all the errors are gone, but still there's another problem here. Unsafe code may only appear if compiling with unsafe. Okay. So it's one of the ways of dealing with unsafe code. Declare the class as what is unsafe. But if you see the error persists, try to change where to declare the word unsafe. Let's declare it on the methods. Let's declare it on the method. Which one? Public void square. Let's declare it on the method and see what happens. Public unsafe. Public unsafe. Okay, public unsafe. There you go. Yes, the error is gone on this side. The error is gone on this side, but it's still there. At the top, it's still there. It's still at the top. It's still at the top. So how do you handle that? Right click on the solution explorer, on the solution on your program, pointers, right click on the solution explorer, right click, then you go to properties, right click, properties, then there's what? Application build, events, package debug, signing, blah blah blah. You click on build, then look for allow unsafe code, allow unsafe code, allow unsafe code, allow unsafe code. Take that, allow unsafe code. Automatically your error will disappear. You see, and all the errors are gone. All the errors are gone. Why? Because you know what you're doing. Because .NET wants to know if you know what you're doing. So if you know, you know. Wants to know if you know what you're doing, that you are working with unsafe code. So do you understand the dangers that you may end up formatting RAM, deleting some things on RAM? Yes, allow unsafe operation. This is an unsafe operation. It's an unsafe operation. This is an unsafe operation. It only requires people who know what they're doing. The rest, that's what we say, don't try this at home. Don't try this alone. Don't try this alone. Otherwise, you'll be in serious trouble. You'll be in serious trouble. So you allow unsafe code. Okay, so that's the first part. The second part now of the lecture says passing data to pointers. Passing data to pointers. Passing data to pointers. How do you pass data to the what? To the pointer. So now, okay, we want to pass values to the what? To the pointer. So our pointer int I. Let's assign a value. Int I is equal to 10. That's our pointer. Int I is equal to 10. Int I. So want to pass this 10. Want to pass this I to our pointer. Want to pass this I to our pointer, which is dealing with this method square. Oh my good, do I still remember these things? Square, open bracket, then yeah, ampersand, this character, ampersand, then I, exactly. There you go. That's how you pass the what? That's how you pass, a value to a pointer. That's how you pass a value to a pointer. We use this character ampersand. So we use this character to pass values to the what? To the pointer. We use this to pass value to the what? To the pointer. Okay, there's still an error there. There's still an error. If it still persists, you can also put this method under unsafe as well. Like you go, unsafe. There you go, unsafe. Then open curly, unsafe, open curly. Then you close your curly. Unsafe. Okay, an object reference is required for the non-static field method property square. An object reference is required. An object reference is required for the non-static. Okay, can we say public static? Okay, let's just declare it as a static method. Okay, let's declare as a static method, then the error disappears. Public static and safe. Okay. So there we go. We've passed what? We've passed I into the what? Into the method. So whenever you're working with pointers, either you're multiplying, you're doing what? That's the character which you use to pass to pass data to the pointer, this ampersand. So that's unsafe code number one. That's passing a value to what? To a pointer. Okay. Then we get our outputs, control.out.println, sorry, system.out, not system, console.writeLine. Hey, I'm coming from Java. If you're coming from Java, you still speak the Java language. So we print out our I, right, run the application. So there we go. Our answer is 100. Our answer is 100. Why? Because we are saying I multiplied by what? I multiplied by I. But we are no longer using this. We are using the pointers. So the answer of I multiplied by I is passed to the what? To the pointer. So it's no longer I multiplied by I, but it's now PI multiplied by PI. And in PI, we are passing this value of what? Of 10. That's what we've done in this short program. We are working with pointers. We work with pointers, pass the values to the pointers, declared and safe code. To still persist, you go to right click on the pointers, then properties, then build, then allow and safe code. Otherwise, we have some problems. We have some serious problems. You see, you have some problems. You won't be able to work with this unless and until you say allow unsafe code, then all your problems disappear. And you get your result. Okay, are there any questions? Working with pointers, are there any questions? Are there any questions? All right, so that's how you work with pointers. That's how you pass values to the pointers. That's how you declare. That's how you declare that I'm working with what? I'm working in an unsafe zone. I'm working in an unsafe zone, unsafe. I'm working in an unsafe zone, unsafe. So allow me passage. I know what I'm doing, man. Say, I know what I'm doing. Yes, I am working with I know that I'm working in an unsafe zone. I know. And I won't mess up with memory. I won't mess up with what? Because I know my story. So allow and safe code, visit on build, allow and safe code. I know my story. You allow that. Then you're good to go. Otherwise, you won't be able to work with pointers. Without that, you are not allowed at all to work. So today I've given you a license. If you want to work with pointers, there you go. But make sure you know your what, you know your story and you know your stuff. But the advantage of working with pointers is that execution speed is improved. Why? Because pointers are closer to the what? Pointers are closer to the assembly. Language. They are closer to the assembly language, which means fewer instructions are issued to the processor. Fewer instructions are issued to the what? They're issued to the processor. Fewer instructions are issued to the processor. Unlike when you work with this one requires a lot of instructions to be issued to the processor to work, to interpret, to compile all those phases, lexical analysis, syntactical analysis, target code, what, so many instructions. But this one, just few instructions. So it speeds up the execution of the application. Okay, so there we go. Okay, without taking time, you are supposed to design an application today. The remaining time, you are going to design an application. You're going to design an application. Design an application demonstrating the use of pointers. We're going to design an application to demonstrate the use of pointers. That's what we're going to do today. S for your eyes, S for your what? S for your activities. There we go. Activities. What was the last activity? Sorting algorithms. Which one is the efficient? Oh, that was for yesterday. Okay. All right. We keep on piling them up. One day is one day. All those answers will be required. One day is one day. All those answers will be required. All those answers will be required. One day is one day. So it's ICE task number 6. 5. Number 6. This one is on what? Pointers. Pointers and unsafe. And unsafe code. Pointers and unsafe code. Okay. Create an application in C#. Demonstrates the use of pointers. Use of pointers, spelling there. Use of pointers and unsafe code. All right. 20 marks. 20 marks. There we go. And this also goes for group 2. This also goes for group 2. This also goes for group 2 as well. This also goes for group 2. More resources. ICE activities. 1, 2, 3. Oh, so it was number 5. Okay, so I think I'm moving to. I'm way ahead. It's my ICE task. Let's see. ICE task is 5. Okay, it's pointers and unsafe code. Control V. Out of 20. Submit. Then for group 1. For group 1, it's ICE task number 5, not 6. It's ICE task number 5, not 6. It's ICE task number 5. There we go. Submit. So you are good to go. You are good to go. You are good to go. Any issues? Let me know. Let me know any issues, guys. Let me know any issues. Let me know any issues. Let me know if there are any issues. Not typed out. You have to submit applications now. You have to submit applications. We don't do typed out things. You submit your application. What I test is I run applications now. So you need to submit your application. Then we'll run the application from this side. Then they're good to go. We just typed out. No. That was a demo. That was a demo. That was a demo. You need to do yours. That was a demo. You need to do yours. That was a demo. That was a demo. You need to do yours. Okay. Are there any questions? Okay, so there being no other business, you're good to go. You're good to go. Let's get down to business. Let's get down to business. The remaining time, let's get down to business and you submit that thing. Let's get down to business and you submit that thing. Okay, so we'll see each other. I'm not sure this week or next week. I'm not sure. Yes, with the touch of pointers and unsafe code. Exactly, just a touch of pointers and unsafe code. Exactly. So it's just for your practice, man. It's just for your practice. Just need to practice this. You just need to practice this. Okay. So I think we are good to go. We'll see each other next week, or if you're meeting this week, I'm not sure, but we'll meet whenever we're going to meet on the timetable. I'll be there for you, and we'll see what we can do next. So we are moving with our syllabus. We are now on learning unit number 2. Thank you so much. Thank you, Gabriel. Take care, guys. Cheers. Sharp Pravesh. Yatin, my man. Thank you. You're welcome.